In today's lesson, we're going to look at how we can render data from an API into a React component. So far I've built up a skeleton application that we can use. On the left-hand side here, you'll see this app component, and it's rendering an instance of this GitHub component. We give the GitHub component one property, the username, which in this case I've set to the string Jack Franklin, which is my GitHub ID. The GitHub component itself doesn't do much at the moment, and it's what we're going to implement in this video. We have this function, URL for username, which can take a username and return the URL of the GitHub API that we should make the request to, and currently the component is just hard-coded to return the loading text. So what we want to do is wait until we know this component is being placed into the DOM, and then we want to make a request to fetch some data from the GitHub API. React exposes a series of lifecycle methods that are called automatically during a component's lifecycle. One of these is called component_did_mount. It's called immediately after the component is placed into the DOM, and the React docs recommend this as the best place to make network requests. By defining this method on my component, React will automatically call it for me at the right time. I'm going to use the newer fetch API to make network requests. If you're using this in a real-life project, you should be aware that the fetch API isn't supported across all modern browsers, but I'll include a link in the show notes to a really good polyfill that you can use if you would like to use a fetch API in your application. So in component_did_mount, I'm going to call fetch, and we need to give fetch a URL. So I need to call URL for username, and here I'm going to pass in the username property that we've been given. The fetch API returns a promise, and the first thing we do when we get the data back is we need to pass it as JSON. So I'm going to call .then and call the JSON method on the response. At this point, we've now taken the response from the API and passed it as JSON. So at this point, we've got the data and it's passed as JSON. I'm then going to take this data again, which I'll refer to just as D. And in this callback, we need to call setState. So we're going to update the state of the component to have this data from the GitHub API. And I'm just going to set the property GitHub data equal to this D variable. So now when the component is rendered onto the screen, this fetch request should happen and we should get data coming back from the API. If I now go back to the browser and I pull up the React DevTools in my Chrome DevTools, again, I'll leave a link in the show notes to the React DevTools extension, which I highly recommend. You can see here that the GitHub component that has the username of Jack Franklin now has all this state attached to it. It has a GitHub data key, and all this data has come back from the GitHub API. So in my render method, what I might want to do is log out the name that I got back from the GitHub API in a heading 2. However, if we look at this in the browser, we'll see uncaught type error cannot read property GitHub data of null. And that's because the first time this component renders, we haven't yet gone to GitHub and fetched the data. Because that API request is asynchronous, our component needs to be able to deal with having the data from the API, but also not having the data. So what we can do now is we can short circuit our render method if we don't have the GitHub data object defined. So at the top of my render method, I'll say if not this.state.GitHub data, return loading. However, that hasn't actually solved our problem. In the console, we've still got the same error. The error here isn't that we haven't got the key GitHub data, it's that we don't even actually have a state object. So what I'm going to do is initialize the component with a state object that's just completely empty. And when we're using React via ES 2015 classes, we do that by setting it in the constructor. It's important to remember that the constructor takes the properties, and you have to call super on the props to make sure they're initialized correctly. I'm then going to set this.state to equal an empty object. Now if I come back to my browser, you'll see Jack Franklin here. That's because it's refreshed automatically for me. If I refresh myself, you'll see the loading text is briefly on the screen until the API request has resolved and Jack Franklin is then shown correctly. However, we still need to deal with the case of the API request failing. At the moment, we're dealing with it being loading and we're dealing with it succeeding, but we're not dealing with a failure case. So let's change the GitHub username to be a username that almost certainly doesn't exist, and let's see how our application handles it. And now if I come back to the browser, we see we have the 404 failure in the console from the API because there isn't a GitHub user with that name, unsurprisingly. But what's not good is that the browser is completely empty. If you map this to a real-life application where a network request has failed, the user here has no idea what's happening, they don't know it's failed, and we're not giving them any information. So I'm going to create another piece of state called request failed, and it will be false by default. So now I've set the request failed property to false in my default state. We need to check with the fetch API if its request failed, and set request failed to true so we can show something to the user. Now there's a small gotcha with the fetch API, is that by default it doesn't throw an error for bad responses, 400 or 500 errors. So that means if at the end of this promise chain I stuck a .catch on, that wouldn't actually catch the error, because fetch never rejects. What we can do before we start trying to pass the data as JSON and set state is we can check the response and see what the status code was. Based on that status code, we can then either throw an error, which we can catch and deal with, or we can continue on the promise chain and set the data that was successfully given back to us. When fetch gives us back the whole response, the response will include a property on it called OK. OK is set to true if the response was successful, and it's set to false if the response had a status code that's generally considered to be a failure. So what we want to do is set data depending on whether the response.OK flag was true or not. So what I'm going to say is if not response.OK, so if the response did not succeed, I'm going to throw a new error. And the reason I'm going to throw an error is because then in the promise chain we can catch that error. If the response wasn't okay, I'm actually going to throw an error so that we can catch it in the promise chain. And I'm just going to say network request failed. If we go back to our browser now, you can see that GET request failing, and you can also see we had an uncaught promise that the network request failed. So what I now want to do towards the end of my promise chain is catch that error that was thrown if the request was bad. We could do this with a catch, but then there'd be a problem. If at the end of this chain I added a .catch and wrote some code in here, this will catch that error, but it will also catch any error that occurs if this .setState throws. It's quite likely that this .setState could throw if we've made another mistake in our render function, for example. As a side product of calling setState, the component is going to be re-rendered, and if it needs to be re-rendered and we've made a typo, promise is then going to catch that error and not report it to us. This means that then we could have all sorts of conditions where our component doesn't render properly and we wouldn't know about it because the error has been silently swallowed by the promise. So what I want to be able to do is catch any errors that are thrown by this part of the promise chain and catch any errors that are thrown by this part of the chain, because if it can't pass correctly as JSON, we're going to treat that as just a failure. But I don't want to catch any errors caused by this setState call. So instead of catch, I can apply a second function to the then call. This second function will catch any errors that have been thrown previously in the chain, but won't catch any that are thrown by the function that we're passing first to then, because only one of these functions can ever be called depending on if the promise chain has been successful or not up to this point. So this function will take the error, and in here I'm going to call this .setState request failed, and I'm going to set that to true. Now what I need to do, if that value is true, is show to the user that the request failed. And I'll say if this.state.request failed, and we don't want to return loading, in this case we'll just return failed. Back in the browser you can see that we do have the 404, but we now see the failed text. If I refresh, what you'll see is the loading text briefly appear before it fails. To just double check it's all working, let's go back and change the GitHub username back to be my username. So I've set the GitHub username to be Jack Franklin, but if we go back to the browser, we'll actually see that we're still seeing the failed text. As you can see, we still get failed on the screen, even though there was no 404 from the network, it all worked as expected. The problem here is actually a mistake that I made earlier. In the very first promise callback in this then, we're checking if the response was okay or not. If the response wasn't okay, we're throwing an error, and that's fine, but we're not actually dealing with the response being okay. We need to actually return it so that the rest of the chain can take the response and deal with it. Right now, down here, when we're trying to pass the response as JSON, it doesn't have anything to pass because the previous chain didn't return the response. So below the throw error, I need to return response. Now if we go back to the browser, we can see that the text Jack Franklin is indeed shown. In this video, we've seen how to deal with asynchronous data, deal with it being loading, having the data, and also dealing with errors. You might be thinking that there's quite a lot of code that we've had to write to deal with all these various scenarios, and there must be an easier way to do it. In a future video, we'll look at some third-party libraries and components we can write that makes this much easier to do. If you have any questions, please don't hesitate to get in touch, and I look forward to seeing you again soon.